There are many questions which are related to Newton's first law of motion. I want to describe few of them, and I have taken here 11 questions, and I want to describe them one after another. Okay, let's start with first question. Why it is hard to move a suspended sand-filled can than a suspended empty can? What is the meaning of this saying? Let's say we have a suspended can. This is a suspended can. And suspended. And where the question? Why it is hard to move suspended sand-filled can? If it is filled with sand, then it is hard to move this sand filled can. I mean to say, more force is required to move this sand filled can. But if the same is empty, then it is easy to move the same can. Or I mean to say, less force is required. What is the reason? Now we are going to answer this question. The mass of the sand filled can is greater than the mass of the empty can. So the inertia of rest is greater in the sand-filled can than the empty can, because inertia depends upon mass of the body. Against the greater inertia of the sand-filled can, it requires greater amount of force to bring it in motion. On the other hand, the empty can has less mass. If it is empty, then it has less mass and less inertia. So it requires less amount of force to move it. This is the answer. Okay, let's talk about second one. How can you prove that inertia depends upon mass of the body? We can prove this way. When we push, let's say this book is on the table. When we push a book lying on the table, if it is pushed, then it requires less amount of force. But when a big pile of book, if not only one, if we have many books piled up, and uh, if there is pile of book we have to push on the same table, then it requires lot of force. Now it requires lot of force. What it mean? Both of them have inertia of rest, but the mass of the books in a pile is greater, so it has greater inertia of rest and requires greater amount of force to overcome greater inertia. It proves that inertia depends upon mass of the body. Now let's go to another question. Why the body of the passenger turn towards right hand side if a moving bus turn towards left? This is a bus, and if it turn towards right hand side, then body of the passenger move towards left hand side. I mean to say, it turn towards left hand side. What the reason? According to Newton's first law of motion, a moving body tends to continue its state of uniform motion in the same direction. This tends to continue in its direction towards the same motion towards the same direction. That is in a straight line. That is in a straight line. So at the point of turning, when it turns, at the point of turning, it tends to continue its previous direction, the same previous direction, that is towards the right hand side. If it turn towards this, then it tends to continue the previous direction. That's why it turn towards left hand side. Therefore the body turn towards right if the bus turn towards left, and just opposite of this, if turn towards left, then the body turn towards right. It is also known as inertia of direction. Okay, let's go forward. Question number 4. Why a man alighting from a moving bus falls forward? This is one of the question. Now we can say like this. A man a man alighting from a moving bus has inertia of motion. Actually, if a man comes out of a bus, his body has inertia of motion. When his feet touches the ground or touches the road, it comes to rest. Feet comes to rest. But the upper part is in the motion, and according to Newton's first law of motion, it has inertia of motion. It has inertia of what? Motion. And tends to continue its state of motion, therefore he falls forward. This is the answer of this question. Now let's talk about on the question, when a galloping horse suddenly stops, the rider falls forward. Why? The body of the rider of a galloping horse is in motion, and according to the Newton's first law of motion, it has inertia of motion, therefore it tends to continue its state of motion even when the horse suddenly stops, so the rider falls forward. Now another question, when a horse suddenly starts to move, the rider falls backward. Why? When actually this question is just opposite of the previous. At first the rider was at rest, and according to Newton's first law of motion, his body contains inertia of what? Rest. His body contains inertia of rest, due to which it tends to continue its state of rest even when the horse suddenly moves. Therefore the rider falls backward. This is the answer of this question. Now let's talk about number 7. Why an athlete runs some distance before taking a long jump? This can be answered this way. When an athlete takes a jump, then the body gains the inertia of motion by the applied force on the ground. And if he runs some distance before the jump, then the inertia of motion gained by the body due to the running will be added up on the body at the time of jump. Thus, to gain the greater inertia and to jump long distance, an athlete usually runs some distance before taking a long jump. Okay, now let's go to question number 8. A ball thrown upward from a bus moving with constant velocity returns to the thrower. Why? Actually, according to Newton's first law of motion, both the moving bus and the thrower have inertia of motion. So the ball shares the inertia of motion of the bus even when it is thrown in the vertically upward direction. So it covers the same horizontal distance as the bus and the thrower covers. Therefore the ball returns to the hand. Okay, let's go to another question. Why a cricket bowler run some distance before bowling? This question can be answered same as the question number 7. This athlete, why he runs some distance before taking a long jump. This answer of this is similar to question number 7. That's why I want to go to another question. Why a passenger alighting from a slowly moving bus runs towards the direction of the bus to avoid falling? If you have seen, if a bus is slowly moving, then the passenger can come out of the bus, but he tries to prevent falling, running towards the same direction few steps. Okay, what is the reason? The passenger alighting from a moving bus has inertia of motion in his body. If he runs in the same direction, then what happens? The bus, where the bus is moving, then he can decrease the inertia of motion gradually by decreasing the running speed, and he can safely stop his body. Otherwise, his feet comes to rest when he lands on the ground, and the upper part continues its motion according to Newton's first law of motion, and he will fall forward. That's why, to prevent falling forward, he will run few steps in the same direction. Okay, now another question. Why a moving fan continues to move for a while even after it is switched off. A moving fan, actually, a moving fan is in motion according to Newton's first law of motion, and it has inertia of motion and tends to continue its state of motion. So it keeps on moving. Later it comes to rest due to the external force, that is friction. There's many questions and few of them are taken here, and all of these questions are related to Newton's first law of motion. What do you think? This question and answer helps you to understand Newton's first law of motion and its example or not. If you feel you are benefited by this, please like it and subscribe my channel and share it to other also. Okay, this much for today.